say that charge represents to the electron? Well, we are having positive charges as well, I agree. But since I'm talking about the flow of charges, the charges are basically like, they are the negative charges, because the electron is the one that is mobile and it is able to move, right? So whenever I wish to say that the flow of charges, I wish to say about the electron, that the electron is flowing, right? But like, what about the direction? Here in the same thing, you can find that the charge q is flowing in this direction, right? So I said that the current is present, the current is in this direction. But what, instead of this, I am having an electron, a negative charge. So if I say that the, but it will give you a better approach to solve the capacitor question, to solve the resistor question, which are the questions that are asked in the examination. Like, you can expect that some of the topics may be skipped, which are frequent, but these two topics, they are frequent and they are never gonna skip. Okay, so yeah, let us begin with the topic of current electricity. For the very first, by this time we were studying electrostatics. That means the charge was static, and we were talking about charge. We are not talking about the word current. So first, let us know what is the meaning of the word current. If you remember, current is basically flow. Current is referred to as flow. So flow of something, that is known as that is known as current. So if I am using the word electric current, what does that mean? That means I am talking about the flow of charge. Flow of charge. The flow of charges is known as electric current. The flow of charge is known as electric current. Okay, but in general, the definition is what the rate of flow of charge. Flow of charge. Okay, basically, if anything is flowing, so definitely I'm not calculating it as a whole. I'm calculating it with reference to the time. So yeah, the rate of flow of electric charge, that is known as current. So I can say that current is represented by the symbol I. Okay, or you can represent by small I. Well, my preference is use small I because that is so easy to in your numericals. Okay, so the rate of flow of charge through a cross section, placed perpendicular to flow, placed perpendicular to the flow of charge, So let us say, I'm giving an example. Let us say that this is a conductor, right? Now this conductor, as you can see, that it is having a cross section area A. So there are various charges that are present here. Okay, now these charges, okay, that flow per unit time across this cross section, that will be forming the current, right? So I can say here that the value of current is what? It is dq by dt. What is dq by dt? The rate of flow of charges. Okay, so this is the value of instantaneous current. The instantaneous current is represented by the formula di is equal to dq by dt, talking about the average value. So the average current can be written as delta q by delta t. Okay, got it. So this can be represented as q2 minus q1 by t2 minus t1. These are basically the different forms of the charge which we are going to deal in the question set. Okay, but first, what is the value of the current? Current is rate of flow of charges. Therefore, this can be written as di is equal to dq by dt. Okay, for the average value, it is delta q by delta t, that is q2 minus q1 by t2 minus t1. Or I can write it in more simple terms as ne by t. The number of charges multiplied by the charge in each charge, that is E per unit time. Got it? I hope that is clear. So out of everything, what is the most important formula? The most important formula is that the instantaneous value of current is dq by dt. Got it? Now if I just change the terms here, okay, if I just change the terms here, I can replace it as dq is equal to integral I dot dt. Well, this is also one of the important formula that you will have while doing the questions. Okay, so q is equal to integral I dot dt. This is also something you should know. Okay, I hope you got it. Perfect. So what does it mean if I draw a graph? Okay, fine. If I am drawing a graph between what and what? If I draw the graph between q and t, the slope of that graph will give me the value of the current. The slope of the graph will give me the value of the current. Okay. Instead, if I draw the graph of current and time and the area under the slope, this will give me the value of the charge. Okay. I hope that's clear. Okay, perfect. So from all this conversation, I simply know that current is the flow of charge. But like, if I'm talking about the charge, okay, in basic terms, can I say that charge represents to the electron? Well, we are having positive charges as well, I agree. But since I'm talking about the flow of charges, the charges are basically like, they are the negative charges, because the electron is the one that is mobile and it is able to move, right? So whenever I wish to say that the flow of charges, I wish to say about the electron, that the electron is flowing, right? But like, what about the direction? Here in the same thing, you can find that the charge q is flowing in this direction, right? So I said that the current is present, the current is in this direction. But what, instead of this, I am having an electron, a negative charge. So if I say that the negative charge is flowing in this direction, you will say that the direction of the current is opposite to that. So what I found from here, that the direction of electric current, is along the flow of positive charge. It is along the flow of positive charge. Okay, well, if you talk about the negative charge, so you will find for negative charge, the electric current is opposite to the direction, opposite to the flow of negative charge. So that means that if I'm having a positive charge q, okay, and I'm having a negative charge e, so if this is the direction, if I'm just so sorry for that, yeah, if this is the direction of flow of your charge q, so you will find that the direction of the current is also this way. But instead, if you're having the flow of charges of electron as this way, you'll find that the current in this direction is opposite to that. Okay, is that clear? Okay, so does this, like, okay, I got it that current is something that whose direction has to be also determined. So can I say that electric current is vector? Can I say that electric current is vector? Electric current is a vector. The answer to this is no. Electric current is not a vector. Okay, it is a scalar quantity. It is a scalar quantity. Okay, it is a scalar quantity. Then why I am discussing about the current of this? For the sake of conservation, which we'll be discussing in a bit later on. Okay, so this is not like that. Okay, simply what I mean to say, it is a scalar quantity. But okay, so I can say, so it does not follow the vector law of addition. The vector law of addition. It does not follow the vector law of addition. Okay, so it follows what? It follows scalar addition. It follows simple scalar addition. Okay, like why I'm stressing about this? The reason is, like, if I say that this is a junction, okay, basically these are current wires. From here 3 ampere has been reached. Here from here 4 ampere has been reached. Okay, and let us say that the junction is meeting at an angle of 90 degrees. So what is the current that is flowing through this wire? You will find that the current flowing through this wire is 3 plus 4, that is equal to 7 ampere. From here 7 ampere is flowing. So this is a simple addition law. 3 plus 4 is equal to 7. This is my simple addition law. Okay, so this is scalar addition, which in the case of current is known as Kirchhoff, which in the case of is known as Kirchhoff first law, which is also known as the junction law. This is also known as the junction law. Got it, guys? Perfect. What is the unit? What is the unit of current? Well, talking about the unit of current, the unit of current is ampere. The unit of current is ampere A. Okay, and what is the dimension of this? Well, talking about the dimension of current I, this is A. Simple, this is A. Okay, if you remember, we are having 7 fundamental physical quantity. If you remember, the unit for that was A for current. Got it? Okay, that's good. So with this, let us begin the initiate a question and check whether you have understood this or not. Simple question: a 0.5 mole of electron flows through a wire in 8 minutes. In 8 minutes. Okay, find the magnitude of electric current. Find the magnitude of the electric current. Okay, so like, just try to find. Okay, repeating the question, that half mole of electron is flowing through a wire in 8 minutes. Then what is the magnitude of the current? Well, just try this. Okay, so what is the amount of charge I am having? I am having 0.5 mole of electron. What does 0.5 mole of electron mean? Since I know that 1 mole, which is 1 Na, so 1 Na is 6.022 into 10 to the power 23 units. Okay, entities, which you call entities. So since I can say it's 0.5, so I can say half into 6.022 into 10 to the power 23. Okay, this is the amount of charge. This is the number of electron. This is the number of electron. Okay, what is the value of current? Current is number of electron multiplied by the charge of each electron upon the time. So it's half. Okay, it's 3.011 into 10 to the power 23 into 1.6 into 10 to the power minus 19 upon the time taken. Now what's the time taken here? The time taken here will be equal to 8 minutes, which you can say 8 into 60, that is 480 seconds. So yeah, 480 seconds. So 480. Okay, simply multiplied with 10 and multiplied with, okay, well, that's not needed at all. Okay, let's keep it as simple. This is 1.6. Now I can say that this is 10 over here 16. This is the value of 30. Okay, if I just keep it simply 3, if I just simply keep it 3 for the sake of good answer, so this comes to be 10. So this is equivalent to 10 to the power 23 minus 19 minus 2, that is equal to 10 to the power 2, which is equal to 100. So 100 ampere of current has been flowing through this wire, almost 100. Okay, I hope you got it. Okay, if yes, then do this question. The question is, flow of 10 to the power 7 electron per second in a conducting wire constitutes a current of how much? You have to find that how much current does it constitute. Well, good question, just try this. Okay, I hope you have tried this. So yeah, the flow of 10 to the power 7 electrons. Okay, the number of electrons is given as 10 to the power 7. Okay, per second means per unit time. So this is the value given here. Now you have to find that how much is the current here. So current is Ne by T. This is given as 10 to the power 7. So I can write 10 to the power 7. What is the unit of E? That is 1.6 into 10 to the power minus 90. Simply 1.6 into 10 to the power minus 12 ampere current is flowing through the given cross section. Got it? Okay, next question. This is a good one. Question says, if Q is equal to T square plus 2T, find the value of I, that is current I at t is equal to 2 second. Okay, and find second, you have to find the average value, average current from 0 to 2 second. Well, just try this. First, find the current at t is equal to 2 second. If you read the question carefully, you will find that the question is asking me for the instantaneous value, and this is asking me the average value. You know the formula, just go ahead. Okay, let's start solving it. So what does it say? If I talk about the first portion, that is instantaneous current, q is given as t square plus 2t. So I can say that the value of instantaneous current is dq by dt, that is t square plus 2t upon dt, that is equal to 2t plus 2. Okay, at what? At t is equal to 2 seconds. So put the value 2 into 2 plus 2, that is equal to 6 ampere. So at the moment of 2 seconds, the current that was there is 6 ampere. Now what is the average current that has been flown from 0 to 2 seconds? Well, if you remember, I average is simply delta q by delta t, right? So I can write q2 minus q1 by t2 minus t1. What is q2? So it's finally I am at 2 seconds, and initially I was at 0 second, right? So this can be written as 2 square plus 2 into 2, okay, minus 0 square plus 2 into 0, okay, upon t2 minus t1, that is 2 minus 0. Got it? So this can be written as 8 minus 0 upon 2, that is simply 8 by 2, which is equal to 4 ampere. So at 2 seconds I was having 6 ampere, but during 2 seconds I was having 4 ampere. This is very important for you to read the question carefully, whether the question is asking me add or in. Okay, if the question says add, that means you are being asked the instantaneous value, but the moment you see in, that means you are asking the average value. Got it?
Problem is not effort, it's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.